Hello, my name is Danielle, and I'm going to be talking to you guys about the 5 practices for orchestrating productive mathematics discussions. This book is published by through the National Council of Teachers of Mathematics, and it's by Margaret S. Smith and Mary Kay Stein. It's a great book for teachers to be, just like me. So the 5 practices that they list, the first one is the anticipating, going through possible solutions beforehand. The second one is monitoring students. The third is selecting, so selecting what you want students to provide for this class and sequencing how you want them to. And the fifth one is connecting them all together, connecting those equations and what they find back to the problem and the solutions. So I'm going to be doing a math problem to incorporate these 5 practices and show you how they would work in a classroom. So I wanted to do the area of a triangle and having students figure out how to find that without necessarily knowing the equation. So the problem I have is if the length of side A is 4 centimeters and the length of side B is 2 centimeters, what is the area of the triangle we have in front of us? So the first step we have is anticipating, like I said. So during the anticipating stage, you want students, as a teacher, you want to be thinking about what students will be finding and what they are going to think the answer is going to be and how they find that. So you as a teacher want to be anticipating all the different kinds of correct and incorrect answers that students might have in regards to this story problem. So the first one that I thought of was if students simply added the 4 and 2 together to get 6 centimeters, which obviously isn't correct and doesn't show the area in any way. And additionally, they wouldn't have centimeters squared because they don't have the area. The second one I found was perimeter. So them kind of guessing that 2 and 4 would make the third side 6 and adding those up to get 12. In which case they would be kind of trying to look for the perimeter and not the area. The third one I anticipated was them multiplying 2 times 4 without thinking about the triangle instead of a square. So having students, when you are selecting and sequencing, which we'll get to, having that connect to the area of the rectangle, which is base times height, and kind of prompting students, if they are doing this, kind of prompting them to think about the relationship between a square or a rectangle and a triangle, and kind of getting them to come to the conclusion to themselves that half of a square is a triangle. So the first 2 are obviously wrong. The third one is not complete. So it's a great place for students to start, but it's not a completed thought yet. So we really want to push students a little bit further. So the next anticipation would be that students would understand the equation, but not understand how to have that through the picture. So students would have area equals 1/2 base times height and find that it's 4 centimeters. I forgot the squared at the end, but you want to have the squared. And then kind of gauging and figuring out how to prompt them and how to connect that back to the picture. So it's all about connecting at the end, which we'll get to. But anticipating how students are gonna solve the problem and what their reasoning behind those are. So after you have the idea that students find it with the equation without the picture, you can anticipate that students are going to, some students at least, might possibly connect it through a square and build the other half of a triangle to get a square. And they know that the square's area would be base times height, which is 4 times 2. But they would also have to know, and you might have to help prompt them in monitoring that the triangle they're looking for is half of the square that they just found. So they would have to divide it by 2, and I found that squared. There you go. So it'd be 4 centimeters squared. And students might have that first part where they're connecting it to that square, but not necessarily remember at the end to have to divide. Another possibility that I thought of, which would be a bit harder and you might not see it, but it would be good to anticipate it anyway, is having students draw a square within the triangle that divides each of the sides in half, so that you would have the 2 centimeters be 1 and the 4 centimeters be 2 for each of the halves of the side. And then looking at that triangle, you can move that down to create another square. And so that 2 becomes a 2 over there. And that 1, that 1, that 1, that 1 are all parallel. So the squares are both 2 centimeters squared, because it's a 1 centimeter by 2 centimeter square for each of them. So if you have 2 squares that are both 2 centimeters each, then your answer for the area would be 2 plus 2, and that would be 4 centimeters squared. Now that's probably a little bit tough, and you probably won't see that, so it's just good to anticipate. And it's important to remember, anticipating is preparing, so you want to be prepared for your class before you walk in and start teaching that lesson. So the second step is monitoring. So the teacher needs to be observing students and observing the class as they're working through the story problem to help them if they're stuck or if they're in the wrong direction, to help them work through the problem and work towards the right direction, towards the right solution. And you want to look for those methods that you were anticipating. You want to look for those methods in your monitoring of their work and their solutions, so that you're not caught off guard with their answers and not understanding where they got it from. Your third one is selecting. So after you've monitored and during anticipating, you're going to be wanting to think of how you're selecting this, but you're going to want students to present their observations and their solutions to the class. So you're picking students, so Sarah, Josh, and Lily, you're selecting those students to present to the class based on the solutions that you saw that they had. And for the third practice and fourth practice, selecting and sequencing, they're very similar steps because you do them often together. So you're selecting, for instance, Sarah, Josh, and Lily, and you're sequencing them in that order depending on the way that they found the solution to the problem. You want to make sure that when you're having them present that you're not setting them up to be embarrassed, and you also want to choose students to present their ideas, but keeping in mind that you want all students to be participating, so that they are all involved in the classroom and that there isn't 1 or 2 students that are always participating. So lining up that sequencing so that students are all participating, all having a turn, and that they're all going in a sequential order that's going to be understanding for the other students. Your last practice is number 5, connecting. So as a teacher, after your students have presented their ideas, you want to really, really help connect their solutions and all their ideas back to the problem and connecting it all together to find your answer, make it understandable. Connecting is so important, to connect it to pictures and have students understanding how the problem works and how the equation is built, so that they can remember it a lot better. So this book is super helpful. I would really, really suggest it to you teachers to be. Again, it's the 5 Practices for Orchestrating Productive Mathematics Discussions by Margaret S. Smith and Mary Kay Stein. Thank you so much for watching. Please subscribe, and I hope you guys have a really, really good day. Thank you.